All right, our next example for implicit differentiation has a little bit of nonlinearity, about the most friendly kind you can imagine. We all know y equals x is this parabola, right? Y equals x squared. What about y squared equals x? Well, we've kind of flipped the meaning of x and y, so we're flipping around the 45-degree line. So we get a parabola like this, a sideways parabola. And you might say, well, I could solve this and get y equals root x. That's true, but what about this lower branch? For those, if y is negative, but when you square it, you get a positive answer, so that could be equal to the positive x values here. So we've got this whole sideways parabola. What if we want to know the slope on it anywhere there or there? Then we could say, let's do implicit differentiation. So let's take d dx of y squared equals x. So take the derivative of the whole thing with respect to x. That'll give us d dx of y squared equals d dx of x. So one side is easy and one side is difficult. What is d dx of y squared? Well, we got to use the chain rule. We'd say this is d dy of y squared times dy dx. Can you see how the dy's would kind of cancel and you'd be left with d dx? And then what is d dx of x? Just the derivative of x with respect to x. The nice thing here, the reason why we did this, is if I just asked what's d dx of x squared, you'd say it's 2x. Well, now it's the same thing, but just with y. So I can say d dy of y squared is 2y times dy dx equals 1. And then to get just dy dx all by itself, just divide both sides by 2y. So I'll show that in a separate kind of color here. So then we'll have dy over dx equals, actually divide both sides by 2y, I forgot to say. So then we'd have dy over dx equals 1 over 2y, which is a little interesting because our formula for dy over dx usually has x's in it but not y's, but here it has a y. Now you could, if you really wanted to, go back and solve this for y and plug it in here, but that's not the main point we're going for. Although some textbooks want you to do that, but here we're happy writing it that way. So that works so well. Let's try another one, and the next one we'll try as a circle in the next video.